Hello, and welcome to another edition of DevOps Dialogues, Insights and Innovation. My name is Paul Nashwati, and I'm the practice lead for AppDev and App Modernization here at the Futurum Group. And today I'm joined by VP and practice lead, Dr. Bob Sutor. Bob, would you like to introduce yourself?
Sure. Hey, Paul. Well, I joined the Futurum Group, just to be clear, 2 months and 2 days ago. So I'm relatively new in this role of analyst, but I've been around the industry quite a bit. I spent almost 4 decades at IBM on the business side, but also in IBM research, doing quantum there. I was with Inflection for a couple of years. They do all sorts of quantum things. I do have a bit of an AI background, though, within IBM. Some of the more advanced topics, I would say. Not everything in AI is off the shelf. Sometimes you need a bunch of people to figure out how to do the problem the first time and maybe the only time. So I have a broad range of experience in these technologies, and I was really looking forward to being on this because I was thinking back a little bit to my programming experience, my coding experience, as we like to say. And I don't want to scare anybody, but I've been doing it for 50 years. And I started when I was a teenager. But that does not mean I've been coding in COBOL for 50 years. I want to be very clear. I've used one of everything. So.
Well, that's great, Bob. And, this is an exciting topic, and we're here to talk about the impacts of quantum computing on AI and DevOps and AppDev. And you certainly bring a plethora of knowledge, right, to the space. Mm-hmm. Talking about the background in space. And I've had the pleasure of interacting with you for several years now in the different capacities. So I'm really excited that you're part of the Futurum team, and the quantum practice is an exciting space. So I think we should just jump right into it. And, when we think about quantum, and we think of some organizations are thinking, well, what does quantum have to do with DevOps and AppDev? And why are you on this show, right? And when I think of it, I think about it in the context of, when you and I have spoken and where the future is going. Why don't we tell the audience a little bit about the quantum practice and what's your vision?
Okay. Well, quantum computing is one of these things. People joke it's always 10 years in the future. Don't worry. It'll be really useful in 10 years. Well, the good news is we brought that down to 5 years. It's just always 5 years in the future. Quantum computing has gotten quite a bit of attention in the last almost 10 years now, since IBM put the first small quantum computer up on the cloud a little bit more than 8 years ago. There's a lot of buzz about it. Quantum is this magic word. Somehow you say this and people say, tell me more about it. And they think of quantum leap, right? Or it was Ant-Man, and Quantumania, and things like this. So it's something that almost sells itself as a conversation starter. But it's a very different type of computing. And really the point of it is to solve certain types of problems that we cannot do today with what we call classical computers. And, we talk a lot about the great progress that's being made in GPUs, for example, and underneath AI and all these supercomputers. But there are still problems that would take these supercomputers tens of thousands of years or even millions of years. So there's this great hope and promise, right, that quantum may be able to give us some breakthroughs. In AI, maybe eventually, but healthcare, chemistry, all these sorts of things, financial services. So it's something that is of increasing importance to a lot of Futurum Group clients. They want to know about it. All the attention, though, seems to be on hardware. And hardware is great, but it's software. Software is what implements the applications that people use. It's much less known about. And that's why I think from a DevOps perspective, we can talk a little bit about what this new world is becoming for actual developers.
Yeah, Bob, that makes a lot of sense. And, certainly there's a lot of interest around this, right? And it's really in that education phase, right? It's that kind of understanding what's happening. You wrote a book, right? Dancing with Qubits, right? That's a good way to kind of explain how this all kind of comes together. But I know when I wrote a blog a year or so ago, within a few months, like 2 months, there was over 10,000 views, and it just all was focused around the research and what's going on in the quantum space. So there's just a lot of interest. And I think you kind of nailed it, right? If organizations are thinking about how to solve problems, maybe not with classical computing, but with other approaches and different approaches, quantum may be the approach. So maybe we can touch a little bit about into, say Horizon 1, Horizon 3, or whatever it may be. What is the use cases that would be the right use cases that we would think to in the short term to use quantum versus maybe what's out later?
Well, let me first say there are going to be vendors that are going to argue with what I'm about to say. And so what I'm about to say is that, and I'll try to be a little polite about it, is that for the most part, none of the quantum computers we have today can solve these critical problems that we care about. They are just too small. So, they're not powerful enough. They're too small in terms of the number of qubits. And for those of you who don't follow this, just as we have bits, zeros and ones classically, we have quantum bits, which are very strange objects and behave according to the rules of quantum mechanics, one of the most confusing, crazy, but evidently true models in physics itself. So when you're thinking about coding and you're thinking about these new applications, it's not just like, well, what you used to learn and you learn a little bit more, or it's not like a new language. It's a completely different way of thinking. So we don't talk about what quantum is doing for us today. We talk about what we hope it will do for us in the future. And we can divide that into really three areas as we're thinking about use cases. So anybody out there who's maybe doing classical development, wants to get into quantum, or works for certain types of companies and certain industries. So here are the three. The first is optimization. Now, optimization is a very general type of field. Basically, you have some constraints. You want to do something as well as possible. Okay, that's one. There are some quantum methods to do that. There's been a little slowdown on those. We might need a little bit more, but interesting topic. Very useful in financial services, risk analysis, all those sorts of things. Second is AI, because where would we be if we didn't somehow connect this to AI in 2024? Everybody's doing AI somehow, some way. And before we think too much about Gen AI and all that, we got to go lower than that for quantum. AI is math. When you get down to the basis of it, it's math. So do you have something that can do the math better? And the particular type of math is called linear algebra, if anybody's had that. Basically big matrices. So you think of these huge tables, for example. If you've done video games, right? I mean, it's the same sort of math. You can't do it with GPUs, but it's the same sort of thing. So if quantum can be, if you will, a super math calculator for AI problems, that would be great. Maybe it can help us find patterns that are just not possible classically. And oh, by the way, it's the same math that's used in computational fluid dynamics. Now, isn't that weird? That's, here I'm thinking about AI and all the Gen AI and all the stuff people are talking about. And over there, I'm talking about air flowing over an airplane's wings, right? Or over a car, or water over a submarine, and things like this. The final area, and probably the first really useful one, is chemistry. And you might say, well, shit, I don't do anything with chemistry. Well, if you shampooed your hair this morning, you used something that was the result of chemistry. Material sciences, right? New things in your car. Eventually, new drugs, new antivirals, and things like that. And that's because quantum mechanics is what seems to model the universe. They're very small. And when we get down to the atomic level and trying to figure out what's going on and interesting reactions and trying to come up with fertilizers, for example, a relationship to agriculture that we can create using much, much less energy, we think quantum will have a role there. So in this Horizon 1 or Phase 1, it's mostly figuring out how might we do this, what might the use cases be. Phase 2 is going to be a little bit more of, all right, now let's get practical here. We've been playing around for a while. We've been experimenting. We have a few key problems we have to get through. We have to solve these problems. So we'll be knocking those off. And eventually Phase 3, which I think will be about 2030 or so, that's when we'll start really having the use cases. But for the developers, and I'll conclude this question with this, Quantum is not easy. Don't let anyone convince you. Quantum made easy. Quantum in 5 minutes. No, 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 no. So over these next few years, if you're going to get into it, you got to get into it. You have to start thinking in a quantum frame of mind. It's nothing you've ever seen before, unless you happen to have done a whole lot of physics in your life.
So it's very interesting, Bob, because when I think about today's challenges, what's happening in classical computing, and I think about DevOps, and I want to tie it back to the kind of DevOps and the even
Yeah.
the CI/CD pipeline and the SDLC and such. And whenever I'm talking about my practice, I'm talking about it in the context of past, present, and future. So there's like applications that are heritage that need to be migrated to modernize, and they look at like today's world, and I usually talk about in the context of cloud native and microservices
Mhm.
and such, and that's really cool and that's great. But when we start looking at future, right, there's a development cycle. There's the tactical, what has to happen today, the business KPIs, push code out the door faster. And what we're
Mhm.
seeing in our research is there's just 2 to 3 times more applications being created today than just a few years ago, with a fraction of the resources, people resources that were
Right.
around, which introduces the context of adding in AI, right? And adds in AI for software development, because there's just not enough people or hands to
Mhm.
write the code, right? So if we have more AI and automation, it allows for that. So, but thinking about future,
Yeah.
where organizations are looking at quantum and how quantum looking, can we talk a little bit about maybe some, of the SDKs that are used, the platform or Rust and Python, how it works within the quantum verse? How's that?
Yeah, definitely. And in terms of using AI, Gen AI to write code, I wrote up something about 2 weeks ago for the Futurum group. I picked a very simple problem. I mean, if you think of this, an HTML page, somewhere either at the top of the screen or maybe in the tab, it says the title of the page. It's not profound, right? And I said, all right, write me some Python code that just extracts that title from the HTML, the original source. And I went to 5 online services, and boy, I got 5 different answers. One was wrong completely, right? I mean, I said read a file, it didn't read a file. 2 I thought were really pretty good for a while, and then I realized they did no error testing whatsoever. And then there was finally one that did the right thing. So today, to be clear, classically, we're only at the beginning stages of being able to create code you could trust without going through line by line. I said before that quantum is hard, right? Well, quantum coding is extremely hard, and it's much more like the assembly language sort of code that people did 40 years ago, right? We have some high level languages, and yes, you can create things in Python. And here, as you mentioned, the SDKs, the number one is called Qiskit. Sometimes called Quizkit. It's Qiskit. IBM started it. It's open source, but it has had literally more than 100,000 people use it, right? It's very good. It just went to version 1.0. It's been through iterations with the community. You can write your quantum code. Second one's called Cirq, CIRQ. That's from Google. A little bit less powerful, but very interesting design, as you'd expect from Google, from a very strong computer science perspective. And then there are a couple of other ones, but fundamentally, they're both Python libraries. All right. So that gets you thinking as a coder, DevOps. All right, well, Python's a good direction. What's your tool chain there? What can you use, right, in writing and deploying? Oh, by the way, Paul, you can't actually debug quantum programs because you can't stop them and look at them. So, any developers who are concerned about debugging their code, that's a minor little problem. Research to be done here. Um, so this is what they have to get into. You have to start learning these new APIs. But we've gotten to the point, because remember, we talked about the different phases. In this second phase, we are scaling up from really tiny problems where you can make something that works in your SDK. Yeah, it does kind of a good job, right? But suddenly things start multiplying, many more qubits, doing many more operations. And so the tools themselves are starting to mature. underneath the covers, and IBM has started to do this with Qiskit, is to replace some of the Python with Rust. So that is, you look at the efficiencies in your tools, right? Yes, you want great applications, but to get them and get them quickly, get them efficiently, you need faster, more powerful tools. So you're seeing DevOps, if you will, being applied to the tools themselves in quantum, which is an excellent sign that the industry is maturing.
Yeah, and that just takes the conversation really to that future state, right? So we're building applications, even though they're being built in classical kind of design, but building them that they're future proof or being used. And I don't really like that word future proof because it kind of nothing is really future proof, but like at least it gets you to the point of utilizing where the platform's going and how it's going and thinking about what's the next generation of technology that's going to work. Bob, I want to pivot the conversation a little bit. We talked about
Yeah.
use cases. We talked about, one of the things that didn't come up, and I just kind of not to throw us kind of a curveball here, but when I think about quantum, one of the things that I hear often is the impacts of AI, but also the impacts
Mm.
of say like cybersecurity, right? And when I think about it, and there's rules and regulations that people are putting in place. Nations are putting these rules in place, and quantum is really, really powerful for some of these deployments, or
Right.
maybe really powerful. What stops? And this is kind of more of a theoretical conversation, but what stops a rogue nation from getting their own quantum setup and just break every rule that's out there? And how do you defend that?
Well, nothing. First, I'll answer that question. Nothing, and but there is this idea that we better get there first, right? And let me set up the problem. And the problem really is, I'll phrase it very generally: cybersecurity. Hey, you've got some sort of encryption and decryption scheme that is widely used. Someone else comes along with a new technology that can break that. What do you do? Well, we can talk about crypto agility. Hey, we'll just shift to something else seamlessly, right? It's not always quite so seamless. Uh, but that other thing that can maybe break some of the types of encryption are extremely large quantum computers, by no means the ones we have today. So there's this thought that eventually quantum computers may be powerful enough to break, well, certainly RSA, of reasonable size keys, elliptic curves, sorry, types of crypto, and then various other ones like this. So various people have gone together, a lot of companies, but also NIST, the National Institute of Standards and Technology, have come out with some standards saying these are new protocols that if you use, we believe, it's different from a mathematical proof, but we believe will not be breakable by a quantum computer. So people have to have, as always, an up to date, modern cybersecurity infrastructure. The fear is, of course, that people will go out, these bad actors in rogue nations, whoever they are, and collect data today using today's encryption schemes, save it, and in 5, 10, 15 years, decrypt it using a quantum computer. I'd say, well, Paul, do I really care if 15 years from now somebody can read my medical record? Like, yeah, I probably do care, but it's not that big a deal. Things have been changed. Well, there are many, many secrets, national secrets, government secrets, military secrets that have histories and, or lifespans that are decades, half century, codes, different sorts of things, information. So you have to get a smarter scheme today to avoid this gather now type of situation so people can decrypt it. So it's not so much of a quantum problem, if you will. Quantum will cause the problem, maybe. But this is why security is always front and central. Those rogue nations of yours or bad actors, it's always about security. It's more of the same. So, yeah, get on it.
Yeah. Well, it's just,
Other
I
recommendation?
think that this is a good topic for the audience to kind of keep in mind as they're thinking about the next generation, as they're thinking about looking at those standards. That NIST standards are good. That's the good location to kind of use as a source of
Right.
truth for right now. And if
And
you
we have,
follow,
and we've if I may interrupt, and we have colleagues who specialize exactly in this and cover the so-called post-quantum, right, uh, crypto.
No, absolutely. It's definitely something that the audience should be aware of as we're looking at future state, right? Future thinking.
Mhm.
Keep in mind. Well, Bob, we're coming up to the end. I have one more kind of topic I want to talk about, and that would be the AI and the impacts of AI and what that means to, app dev. How does quantum impact AI? We talked a little bit around it, but what's the
Mhm.
market overall, including like qualifications around, like what is happening in the AI space today with AI with quantum?
Well, with quantum itself, very little. It's really at the research phase of using quantum for AI. A lot of PhD theses are going to be out there. People are beginning to get little hints of, oh, maybe this will be useful, but not really practical. We can, however, turn this around and say, is AI, is machine learning being used within quantum? Quantum computers are extremely noisy, right? And then one way of thinking about this without getting too technical is think of static. You're listening to some sort of music, maybe on a plane, right? And there's all this extra noise, and your brain's pretty smart. You can just make it out. You have noise canceling. Headphones, well, AI will be and is being used for that kind of noise canceling for quantum computation. So the interesting connection here is that we will use AI to make quantum computing better and more powerful sooner, so we can apply it to AI, right? So it's this total story here like that. Um, in general, if I might just say, I've been in a number of client briefings recently, and of course, AI is a big topic for that. And something that hit me was the best AI is the AI you don't even know that's there, right? Where you're trying to do a task and maybe you're doing something today and you say, why is this so annoying? I've already told you who I am, right? Can't you figure out what I want to do? And you're more likely to kind of say, oh, this isn't working, as opposed to saying, gee, that was wonderful. That was a great experience. I did it really quickly. But that's where the AI is going to be this glue between all the information and the processes you're trying to accomplish, and that's going to be the best. Right now, as we always do in this industry, we are geeky. We use technical terms like generative AI, right? Very, very fancy technical things. And in a few years, why is it good for me? What does it? What's its value to me? So there's a lot going on right now. There's a lot of sorting out, but there are some truly innovative companies who are using it for these real problems that we need solved sooner rather than later.
Yeah, maturity in this space is definitely on multiple ends of the spectrum. I mean, on one side, when you were talking, I was thinking about, going to an appointment and having to fill out paperwork and multiple enter the same information on physical
Mm-hmm.
paper and pen on the same form. That's so tedious. And then you have the other side where you have full automation and it's working pretty well. So, but there's a bell in the middle, and I think the learning is going to continue to occur here, and it's
Mm-hmm.
going to continue to grow, especially as we look at that past, present, and future of taking the old and migrating it with the new and bridging the gap between the two. But with that, as we come to the end, Bob, I'm going to give the mic to you and see if you want to leave the audience with any final words.
Sure. Well, what you and I just talked about. This kind of seamless. Don't be annoying. Use AI to make my life easier. Well, you do have to have some guardrails, right? There's a question of privacy. So I do have to give explicit permission. If I want you to make my life easier, I don't want you peeking into things you shouldn't be peeking about, right? The usual topics of bias, right? I think right up there with what the technology is that whatever you call it, responsible AI is a good term for this. It must be one of your primary and first considerations. I mentioned I've been programming for just a little while. At some point, a few decades ago, we started to tell people you must think of security at the very beginning. We're still telling that. One of our colleagues, I saw something said that this morning, right? We're still telling people this. It's not an add-on. Well, neither is responsible AI. Neither is privacy. All these types of things. And in fact, it's going into laws. So whether we have quantum that's going to enhance AI, ultimately it comes down to data. Where's the data come from? And you have to have a fundamental set of principles from which you start. So it's an exciting period. We are sorting all this out. And it's absolutely a remarkable time to be any sort of developer or to be in a company that's creating new products. We've never had this power. We've never had, between quantum and AI, we've never had such brand new, innovative things, tools like we've never had before. So it's going to be a little lumpy for a while, but the possibilities are extraordinary.
We'll figure it out. We'll figure it out together. Bob, it is amazing to be working with an expert like yourself in the field and learning from you from this. This is definitely a growing field. And, we just hit the tip of the iceberg with this because it's really just a little bit of a teaser for the conversation. We'll get, if anybody wants to follow up with Bob and myself, feel free to reach out to us at the Futurum Group. But I also want to thank the audience for watching today's session. This is, like I said, just the early stages of some of this conversation, and we love to continue the discussion with you. So with that, thank you, and we appreciate your time, and have a great day.